Thank you very much. So I think I'll just already briefly mention the bio, and we're not really focusing on, or we don't have a 2 or 3 slides, 10 minutes explaining who we are. We just skip that part. But I think people are smart enough to just Google and see. So basically, we're working long time on mobile communication, last 10 years, and we were part of security and telecommunication. That's a department in Berlin where I also got my PhD, the same place he's doing. So it's been quite heavily focused on telecom research, for example. And since we're doing this since last 10 years. So how many people in the room has know 5G or briefly or something? So there are a couple of people who raised their hands. So I will skip all those marketing slides about 5G. This gives low latency and all something. But I will just come to straight to the point, to the cream. What exactly 5G we're talking about, and what is the first people talking about 5G security concerns and problem, and what this is about. And just to give some small context on first half, and then we focus on the radio protocols, what we've been working on 5G radio side, and how this can be exposed for IoT devices as well as mobile devices. And there are some attacks and something we've covered. But the 5G deployment, so in Europe or in US, what the current 5G is going on. So there are basically 2 types of 5G that everybody are talking about. So we will have a number of devices. Now, this is the phase of an area where we're not talking about connecting mobile device, but allowing 2 devices to talk to each other. So this is the next few years we'll be doing this research, and that's what we'll have a more massive device-to-device communication as well. And since this year we'll have a 5G, it means we'll have a new 5G towers everywhere being deployed. And that's like a new brand 5G towers that will be more than 4G what you have in the area. And those will be connected to the existing 4G core network, like whatever the KPN operator, for example, or Orange or any operator. And that's like one type of deployment, and that is called non-standalone mode 5G network. So 90% of deployment all over the world basically are like this. So this is a low cost where you just use existing 4G network, and you just attach 5G base stations, and off you go. Then you have this higher speed and all this thing you can get with this 5G. So this is what we have, this one. But in order to have ultra low latency as well as the low high Gbps capacity and also cloudification of a core network, then we will have hopefully by next year, I think in Asia, some mobile operators are already doing this. So don't quote me on this part, but basically it depends on what mobile operators are taking a strategy. So we'll have a 5G towers, and then we will attach with this 5G core network, which is completely evolved core network. And this is basically called standalone mode. So many times you will read the report on 5G and people are talking about 5G NSA. It's not an NSA from US, but it's a non-standalone mode 5G. And this is the 5G SA called standalone mode. So these are the 2 types of deployments. And two had a different kind of security architecture as well. The way your data is being encrypted or handled within the core network. So it has a different implication of security as well. Also, when it compares to IoT device as well, or low power battery device in that sense. And why 5G is mostly really important, and really people are talking about 5G. So what will happen in next 20 years? Imagine what could be the changing scenarios, what we're talking about, right? So basically, how many people have a 1 Gbps home broadband connection in their house? 1 Gbps. So I see 2 or 3 hands. If you are from Finland, I can say everybody has it, but not in every European country you have it. So basically, imagine that if you are getting any wireless device and having 1 Gbps connection no matter where you go, will people start digging the ground cables again, putting the modems or something like this? So this is what 5G gonna bring. It's like you will have a 5G towers, and every wireless device or even every mobile device which you're carrying gonna have at least 1 Gbps speed. So this is what exactly the change we will have it with 5G. And people expecting that maybe this will replace the existing wired cable connections which no longer required, for example. So this means that every home appliance will start talking with base stations. We don't know, maybe it will have a gateway or something like this. But that will be becoming a national critical infrastructure where every devices will be connected to wirelessly, and basically traffic is, or let's put this way, we will have a more traffic which is being handled by wireless networks rather than wired network, or for example, and this has a drastic change in terms of national critical communication as well infrastructure. So this is important in that reason. So let's look at what kind of different model when we now explain slide. I will just try to give small architecture which I use as a base. So it's really generic architecture. So we'll have a mobile phone and base stations. Everybody knows, like everybody's carrying mobile phone, and then it talks to the base station, and that's basically we call radio access network. Okay, that's the left part, and then it is being connected with a core network. So it's in a green right now. Why? Because until 4G, green means that it's pretty hard for an attacker to get direct access to this core network. Of course, you can get access as long as you compromise the mobile phone and then you are attacking a base station or something like this. So it still pretend to be a closed walled garden where it's pretty much secured as long as until you break a physical barrier and not compromise the building, for example. So it's like this. There are some other ways as well to get access, which has been, but I'm not really focused on that one. But still, on an average, is quite secure. And this is what looks like a 5G architecture. So I'm not going to explain you each and every block to get bored you, telling technical what it is there, but this is what changed somehow now. And what is the main point I need to highlight you, what has been changed? What you see on the left side, basically, you have this mobile phone, which is called UE, which is a user equipment, which is with USIM. And now onwards, we may have a more embedded SIM cards other than removable SIM cards. So this is what new trend which we're gonna see now. So you can't remove your SIM card, for example, or your SIM card will be manufactured when the phone is being manufactured. So it's like an embedded on the device. And then we will have a number of base stations. What we say in technical terms is called G node B. And as I told you, in 5G, we will have a more base station than 4G. It means that your base stations may be deployed on the bus stop or a street lamp, so it will be many areas where it may not be secured enough. Physical security will not be good enough. So we have a new architecture called centralized unit and decentralized unit, for example. So we'll have a separation of base stations and the traffic just for protection that angle. And the main interesting thing has been changed is basically what you see in this red block, this goes in a cloud completely. So you can implement all these elements in a cloud, and you no longer need to have a special IT equipments for each block. So you can have the existing infrastructure, let's say any cloud instance which you run on nowadays on a cloud. So any bare metal, for example, and you can just have every block as a slice, for example, or what they say is it could be a slice-based infrastructure. It could be just completely core network running in the cloud. You can have an edge cloud. You can have the centralized cloud. And all these nodes goes into the cloud now, where it's cost-effective, battery-saving, many new features, but at the same time, it introduced a new area of security. And it's a bad, I mean, I can't really say conclusively that as an attacker, you will still get access to this cloud or not. I mean, it depends on the deployment, because this is only one block of a core network, but this network has to have different APIs for different operators, different services to talk to each other. And then these APIs means they have to give access to this core network as well, so that you modify many things as along. So this opens up a new area for research. And what has been evolved in 5G, when we look at this architecture, as I said, the 5G core network has been heavily evolved, and this has been drastic change in 5G. And the technologies we've been using in 5G now, so basically you have a cloud computing, programmable network, mobile edge computing. You read many documents now, people talk about all these technologies, what are the advantages, what is the dynamic aspects we bring into the cloud infrastructure, for example here, network function virtualization. And if you look at the security, actually, each block has its own security implications. Each block has its own security challenges. And now all this has to be combined into the single core network block. So it means that operators are actually has to care about more security of this different angle, which is quite new for them to operate or handle. Like there are many companies who handles one block and they have their own security team which handling many things, for example, deployment. And basically this is runs on the software. And software security is a different aspect again. And again, updatation of those software aspect as well. So this is what the new evolution, and that's what people talk about. It's pretty hard to secure, and how we can put this block to one vendor only and rely on them that they will do security nicely. So what has been changed if I look at this block? So we had this existing network on the left side. So basically, we had a separated core network and RAN. Then we have a dedicated IT hardware, like each block was dedicated IT block, for example, IT hardware block. And also we have a proprietary signaling protocols like SS7. There are many others, but I just give an example of SS7. Of course, you can gain a knowledge about those protocols diameter, but there are not many people who understand those straight ahead, for example. Very few people have knowledge of this. And then difficult to modify or create new services on this block. You can do it, but it takes 1 year time. I don't know how many people are work for a mobile operator here, but using existing infrastructure is quite difficult to start a new services until and unless like a vendor, Nokia, Ericsson provides you some new additional blocks or something. But now if you look at new changes, so we have still there is a separation between core network and RAN, but it's still less separated because then we introduce this edge analytics, or what you say, edge cloud. For example, your connection from base station goes straight to the edge cloud. So it means that it's going into the cloud straight ahead. And then you have a configurable hardware and software in the cloud. And that's what we have, a programmable networks now. And one thing has been replaced classically and drastically. This is a main change. Every protocol which we use in SS7 diameter, how many people know about SS7 flaws and exploit diameter? So some people. And now this has been replaced with a REST-based Java API. I mean, you can imagine this is good thing or bad thing or whatever it is. And of course, there is a security there. And you use SSL and certificate, whatever it is. But if anybody operator sitting in the room, if I ask, them question, do they really care about internal SSL connections or IPsec within their infrastructure? Do they deploy? Very few, yes. And I agree, yes, you should do it. But very people just say, oh, it's intranet, just leave it. And buying SSL and IPsec something else, it costs more again, and our management doesn't give a permission or something like this. So let's have a plain text. So don't care about anything. And that's same going to happen with Java REST-based APIs, where authentication is also based on authentication tokens. How many people really got bug bounty on REST-based APIs or tokens, authentication bypass tokens, something like this? Just find out actually how many people really got many on existing cloud services. I'm not talking about the web services, but still on the cloud, because the Java-based API is also used there. And then we have APIs to create new services, for example, on existing core network. So these are some challenging aspects. It's still good. I'm not saying that it's bad, but it brings new challenges for securing the core network. And let's talk about some 5G, some potential problems we may see here. On the radio side, of course, then we have a device and base station which talks to each other. Still is a wireless medium. Security has been improved a lot. So still, but what we see that a classical design problem, your mobile phone is smart, but and many people say smart means dumb. But I use the term smart means slave. Because your smartphone is a slave, basically, it just acts what base station says. And this has been designed in such a fashion. If the base station says, let's use plain text traffic, or let's use a badly or a less secured algorithm, your mobile phone doesn't have any capacity to negotiate something. It will just say, fine, let's talk plain text because you have the power. So it's a master and slave kind of configuration we have from the architecture. So it's still same in 5G. If the 5G tower says that I don't speak 5G, let's speak 2G, it will just speak 2G, no matter what. So it's just like this. And very, very few phones give you freedom to lock your phone on certain range or frequency. Like you can open your mobile phone and you have network settings that we can say that only 4G or 2G, 3G or something like this. You have this feature. But not every phone gives you this unique features, for example. Or very few phones only have 2G, 3G, 4G or 4G, 3G, but no 4G only. And I assume that this will also happen for 5G, that you will not get only 5G options to lock your phone. But again, this lock mechanism is based on what you see on the mobile device, but not at the end, for example. And then we have a legacy network support, and people also talking about low latency. Many people, you have heard about IoT device on 5G having a 10-year battery lifespan. So of course, there has to be a different kind of security mechanism at that point as well. And that also reduces some security as there. Then we have a classical bidding down attacks. What I said, 5G phones can be bidding down to 4G, 3G, and classical attacks still works. There is ongoing activity going on how to tackle this problem in the 3GPP standardization body, but we'll see what comes out. Then we have a denial of service as on the radio side, and tracking and interception still there, even though we fixed some problems with known networks. And cloud already covered those points. Every point on cloud security, virtualization, third-party API security. This is already a classical problem that we are tackling on the internet world. And this has to be now bring into the 5G networks as well due to the adaptation of softwarization-based, service-based architecture. So this is the SBA, what we adopted in the 5G core networks. Anyway, so this is what we know, and this is one example I just try to explain what this attack means or what something goes bad. This is one use case, for example. So assuming that some mobile operator has been deployed like this scenario, you have a base station, 5G base stations, for example, this way, and this is connected to a cloud base, or this could be the edge cloud. Let's say this is the edge cloud before it goes to the core network. And this cloud instance can be protected using a hypervisor, and then you run different slices, for example, or cloud slices. And one slice could be for one particular service. That's what you see in the marketing term nowadays. And this could be for, let's say, smart grid, national smart grid, or controller, or power or electricity, and one for the normal mobile phone users. And basically, you separate all these cloud instance. And this cloud instance means what? Let's assume that so for example, so this is the mobile phone and he wants to play a game, VR-based game or something like this. So basically when he's trying to access the service, query goes from base station to this block, and they will prioritize, like this is the VR device and he wants the VR service. So basically they will assign him this cloud instance, for example. So data will be handled by this, for example. And this is normal phone and this could be something like this, right? So the point is, each slice will handle a data of particular type of devices, or it could be, let's say, one for autonomous car, for example. We don't know this will come, but so every car data will be handled by one instance, for example. And then this instance block will give access to, let's say, a car manufacturer company or something like this API, and everything will be secured with hypervisor. And now we have to make sure that nobody exploit the vulnerability on hypervisor to get access here, or having the API, or somebody is a smart hacker who use mobile phone and he tried to compromise some elements on here, having 0 day of software or whatever it is. And you have to ensure that these all blocks never really leak any data. So that's what the challenge is, again, when you use this kind of infrastructure. So this is what we have to protect in 5G, having this part. And now everything is running in a cloud, but now I have a really nice example I use most of the time. Basically, this is about Grip wiretapping scandal. How many people know this Greece Vodafone hacking scandal? Very few people know. So what happened back in 2005 around or 6 around? There was one critical software. Basically, every mobile company has to provide an API or lawful interception APIs. So what does it mean? That your every mobile phone call, SMS data, what you use, can be tapped by the government agency as long as they have a court warrant. So you just put any number into the system and that phone will be live tapped. So you will just record every communication call. So this is like an FBI room or monitoring room, for example. It's a mandatory for every operator to do this. And there is a special software for this that you have to build. And there is a special hardware and software, and that has been built by the mobile companies, okay, for this. And this software or this machine was not working properly in Greece. And they couldn't figure out what's the problem there. So they called the engineer from Ericsson, and he came and he started to investigate. And he came to a conclusion that this is not their software. And he said, this is not our software running on this system. Somebody has modified the software and put malware or something like this, and that's what this software is behaving stupidly. And they figure out what it's doing actually. So there was a list of some mobile phone numbers are being tapped to this channel continuously without having any request from government or anything like this. So Prime Minister of Greece and some ministries' call were live tapped by this interface. And the connection was going to some embassies in Greece. So you can imagine, back that time, 2005, we don't know how these systems are designed, what system they are running, how the protocol looks like. Very few people, the telco guys, knows actually what interface looks like. Somebody had a malware for this system or machine, 2005, and it was running smoothly for 6 months until the Ericsson discovered something going wrong. My point is, telcos do not have infrastructure to detect something like this so far. It's getting better, but we still don't have. And this was the case in 2005. And now we are talking about putting these machines into a cloud. And now you have to trust that there is a cloud something. At least now that guy, to install a malware, he has to come with a USB stick or something to modify this machine. Now they don't need to do this. I mean, as long as you own the cloud, I mean, you can just maliciously modify those machines. So that's kind of difference we are talking about now. And this is what kicks the alarm that how many mobile operators have a capability to detect something like this. That's a challenging game. And how do you trust the vendor as well? So this was the case with Ericsson, and still people talk about some Chinese vendor again, for example. Now, I mean, how many people really claim that, okay, Ericsson has really bad code that somebody installed malware on this machine 2005, and now we're talking about one unique vendor and telling that their code is really bad. Now you can compare, I mean, what we're talking about, the code and whatever it is. But the point is, not every telco stack has been properly pen tested, I would say, but I can't come to the conclusion. But still, this is a open ground which hasn't been done properly pen tested, something like this. Anyway, so these are like incidents, and then we also have the incidents like there was a famous French company was pen testing a Belgian operator, and they were fuzzing some packets, and by mistake, few fuzzing packets, because every operator is being connected to each other, some weird request came to Norway, and due to that, the main server of or main component of every mobile operator called HLR, where all the data is being stored of users, got crashed. By mistake, because they were not able to handle 2 packets. It got crashed. It took 3 days to recover it. So that's the kind of readiness we have on the telco infrastructure when something goes wrong in that case. And this is again some configuration operational issues. And still we get outage time to time on the network. And there is a reason of software and misconfiguration issues, for example. And now we are talking about having this in a cloud instance, for example. Of course, we have reliability and redundancy. I'm not saying that, but still, we also have at this stage as well. And then we have a Snowden as well, right? Keys are being leaked with Gemalto was being hacked or something like this. And now we have a 5G devices in future with embedded SIM card you cannot take out. And you will change the operator on the fly. Like when you change from Vodafone to Orange, for example, you don't need to go to store. It will just happen randomly, automatically. Can you imagine a case, you have a mobile phone actually, and you haven't subscribed for any connection, and suddenly you get internet connection. And if it happens by magic, can you trust that it will happen without knowing you as well? Because at least to run my mobile phone, I can put a SIM card, right? I need to put a SIM card. But in future, I don't need to put a SIM card. It's already there. How can I assure that it will not activate it? Because everything comes with the encryption key, which is called OTA key, over-the-air key. And this is known with operator. And again, we are talking about OTA keys are being stored or securely handled, for example. Anyway. And this will be eSIM era. And then we have a different kind of distributed attacks as well, which when you have a higher bandwidth speed, but this is quite logical. I'm not really focusing on. But now we talk about radio part. Let's talk about the radio part, what we have been working on. And there was some research we did in the past couple of months. There was two research we did on radio part about how still some 5G radio protocols, which has been upgraded, but you can still make some attacks, bringing fake base stations, and you can still attack those devices, including IoT devices as well, and mobile devices, and also some ACA protocols, which allows us to build IMSI catcher for 5G devices. And now Altaf will start with attacks over radio access networks.
Okay, so we have seen that like 5G is going to be much stronger network. Like obviously it has to be a bit more stronger than 4G. Not a bit, but like it has to be obviously stronger than 5G. So something that we can actually get rid of in 5G is like the problem of IMSI catching. Like the term, we know that IMSI is something that's unique for every subscriber. So it's a unique number for every SIM card. So in 5G, what they're trying to do is like whenever the device is sending the IMSI to the network, it's actually encrypted now. So basically, no active attackers or passive attackers can actually ask the device for IMSI in plain text. But this is something like implementation dependent. So this is something optional. So we still have to wait and see like who exactly implements this and then get rid of this problem. So we started to like, okay, now we lost the IMSI, we lost the IMEI. So some identities are, like, which can actually help the attacker to actually identify devices or subscribers in the wild. So we started to look, are there any other like methods to actually exploit or try to fingerprint users and devices? So the first one, we came across something like, okay, we started looking and then we found some different methods like to actually fingerprint. So the first one is, we call it like capabilities. So the term capabilities like of a device or a modem, let's say. So when I'm talking about capabilities, I don't mean the processor or the screen or something. So I'm talking more about the modem, like what does the capability of the modem. So for example, there could be two different type of capabilities for the modem. There could be core network and there could be like radio access. So the core network capabilities, this means that these are related to what kind of like security algorithms the device is supporting, or does the device support like GSM railway, or does the device support V2V support, the V2X car driving support, or does the device support like phone calls, SMS, data? So there's like a hell lot of capabilities that the device can actually support. Then on the radio side, so just by the name, you can see that it's something related to the radio. So it could be obviously with the frequency bands, then what kind of like physical layer parameters and some new technologies like MIMO and carrier aggregation, which actually bring the high speeds for LTE networks. And I think they will also reuse the same kind of technology for like 5G to actually boost the speed. So these are some of the capabilities of the devices, and these are actually designed by or specified by 3GPP standards, and are actually designed by the baseband vendors and then pushed into the phones. So these are some of the capabilities for like, this is just Wireshark trace, so maybe just for some reference. So some specific 5G capabilities could be like V2X cars or something cellular IoT specific, something which says like power saving modes, which is really especially useful for narrowband IoT devices. So these are actually defined or mentioned or enabled and disabled in these capabilities, which are actually sent to the network. So if you look now, when we turn on the device, so the device is like asking for a registration request, and then it's exchanging the capabilities. It's sending the core network capabilities. For example, if you are turning on a phone, it says that I'm a phone, and then I need voice calling and then data support, because I can actually handle them because I have some codec support, so I can actually handle voice calls and stuff. So it says that. Then there is authentication security. Very good. Then following that, like the device is sending its radio access capabilities. And then you see that there's an over-the-air security, which is happening just to protect all your data, which is going over the air. So this is something very typical, which happens in 4G and 5G networks. So the basic problem here is like, if you see, the core network capabilities are actually sent in clear text before actually setting up the security. And also the radio access capabilities are actually sent in plain text before actually setting up the security. So we found, okay, these are some two problems, and then we can actually exploit and then see what can we get out of it. So like I said, these are some of the problems, and then this could be exploited in either passive manner, like trying to run a software radio and then passively getting information on 4G and 5G networks. Then also trying to see or like exploit them and then see what can you do with that. So we came out with three types of attacks. The first one is like MNmap. This is almost similar to the NMAP that we have in the traditional IP networks. Then we have a bidding down attack, and then a battery drain attack, which is mostly focused on IoT networks. And then, but these are mostly have to be a man in the middle. So let's go with each of them. And then before actually doing the attacks, like we had to build a setup, trying to really exploit the attacks in commercial networks and then see how they work. So I think people are today like familiar with software-defined radios. So we bought two software-defined radios, USRPs. And then we had some open source software available from SRS LTE. So to actually run a 4G stack. And then we could also modify a little bit the core network, trying to implement new 5G capabilities. So we built a whole man-in-the-middle setup. So basically, it actually has a rogue base station plus a rogue phone, which is actually routing the traffic from the victim phone through this device, through the whole setup, and to the real network. So basically, the whole traffic or the whole registration procedure, which you saw before, is actually going through this one. And then we see at certain points, like, you can actually modify the traffic, but doesn't get detected on either side. Like neither the phone cannot detect it, nor the network can detect it. Like some modification has done. So yeah, the first attack, like the NMAP. Normally we are aware of NMAP, so it means like you try to find live hosts on the network and try to find what kind of like operating systems they're running applications, versions, and then what kind of ports are open. So these are like the typical functions we have. So we try to come up with something similar. So you run a fake base station or something, or a passive device that actually collects these capabilities, and based on the capabilities you collected, you try to identify like who is the maker of the device, the model, the kind of applications it's running, and also, if possible, the kind of application operating system version, and all this information. So how we do this? Like we specify like some kind of like tree model. So basically, we try to find first who is the baseband, whether it's Qualcomm, MediaTek, or Huawei. And then following that, we try to find what kind of chipset number is it, because every chipset you release has a specific number. So we try to find out that number. Then if it's a cellular device or it's an IoT device. Following that, if it's a cellular, then it could be a phone, like not most probably, but there could be other type of devices like routers, USB dongles, laptops, and everything. So if it's a phone, obviously, we try to consider only like Android and iOS. We skip Windows and other. So if it's an Android device, we try to find like who is the actual manufacturer of the device, like Samsung or HTC. Then following that, if it's an iOS device, it could be either an iPad or an iPhone, or like, and try to find what kind of like operating system version it's running. In other type of devices, like we could also identify cars and railway modem devices like differently because their capabilities are different. And coming to the IoT side, like we could actually there are like specifically two types of IoT categories defined in the standards. One is like narrowband IoT, then which is like which has superpower saving mode capabilities. Then on the other side, like there is LTE-M, which is used for like machine-to-machine communications. So this could usually go into like home automation or agriculture or sensor. So these are the typical devices that use this kind of modems. So we could also identify like what exactly the device type is. So if you ask me like why is this identification possible? Two reasons. First one is like the baseband manufacturers, like who actually implement these capabilities, because like all the capabilities are not mandatory to be implemented. So you can actually disable some of them or enable some of them. It depends on the application that's using it. So baseband vendors, like they also implement capabilities differently. Like I said, some of them enable some specific ones, some of them disable it. Then the second reason was like each target application requires like different set of like capabilities. For example, a V2X car should really have this V2X capability like enabled, or else like it cannot activate or use this feature. If you take a phone, it should really support this voice codecs or some kind of like data frequencies or something. So these are like really essential, and then this should be supported by the device to actually show that this application can actually work. So what we did, we tried to build a kind of like a reference model. So we collected like maybe up to 70 to 75 devices, different type of devices. They could be, majority of them are like phones, some car modems, some modems from routers, some modems from like USB sticks, then some devices from the military, some from vending machines, coffee machines. So a lot of devices, and then try to extract the capabilities of this device. Like we try to connect to our setup we have, the rogue base station setup we have, then try to extract these capabilities, just store them. So when we are storing them, we try to store exactly by the name. So the name of it, then what kind of like, who is the baseband maker, then who is the, like what kind of application it's running. So we try to store this in this kind of model and then build a huge set of capabilities. So we try to like find in these capabilities like some fingerprints that actually allow us to differentiate the baseband, because like I was starting with the baseband model or the baseband maker. So if you look closely, like there are certain capabilities which could actually differentiate them. For example, if you take like something called EIA0, it's an integrity algorithm. It's a null integrity algorithm. So basically all the keys are 0. So we found that only Qualcomm basebands have actually have this null integrity algorithm disabled. Rest of them are actually enabling it all the time in all the different type of modems. We don't know like what's the specific reason, but maybe Qualcomm could enable this feature dynamically when somebody is making like an emergency call, or this could be a different reason. If you take something called extended measurement capability, this is something actually enabled only in MediaTek chipsets. Rest of them like disable it. We do not really know the reason, because the problem is here is like these are kind of like optional capabilities. So there's nothing mandatory like the modem should implement them. So once we know who is exactly the maker of this baseband, we try to just Google it and then try to find, because like each chipset has a different name. So, and then each chipset has different kind of like 3GPP release, and it holds like certain capabilities. So if you just go to Wiki and then try to Google which exactly this chipset is, and then we can actually find, if you go to something like Kirin 950, we can actually reveal what devices are exactly using this chipset. So maybe it could list out maybe up to 20 devices, and then 20 of them could be different. Like some could be phones from LG, some could be phones from Huawei, or some could be some other type of devices. So once we gather that information, so the time, like it's now that we identify the application of the device, like trying to see if it's a phone or if it's an iOS device or something. So we have looked even fingerprints for that. For example, like these are some typical fingerprints to differentiate cellular devices from the IoT devices. Then we differentiate between phones and other devices, like there are different voice capabilities that could be differentiated. Then some typical fingerprints like Huawei phones actually only use basebands from Huawei devices. Then there's like mapping. So Apple devices only use chipsets from Intel and Qualcomm. And then, so this was one of the most tricky part, like trying to differentiate like iOS and Android. So there are only certain GPS related capabilities which are enabled in all Android devices but are mostly disabled in iOS devices. Maybe could be like for some privacy reasons or so. So but we found some fingerprints that could actually enable us to differentiate this one. And then we also have like some specific capabilities that can actually help you to identify the version of the operating system, but I'm skipping that. When we're doing this like MNmap, like we have some issues. For example, the biggest issue could be SIM card could be the biggest issue. So when you plug a different SIM card, a different set of bands or different set of capabilities are enabled depending on the configuration on the SIM card. So this could be something tricky when you're doing this kind of stuff. So something interesting what could be done, like, okay, like I said, this attack, like you don't really need to be active. It's also enough that you passively get the capabilities and then try to do the nmap. And then you could link the IMSI to these capabilities and then try to locate or track in specific locations. And then we are trying to share this kind of like all the traces that we have in the tool we built, because like all this stuff is being done automatically. So this could be useful for somebody like who is trying to find out what different devices or yeah. The second type of attack is the bidding down attack. So like I said, this is a man-in-the-middle based. So we have seen that the capabilities are actually being sent to the network before actually establishing the security, like over-there security. So what happens here is like being a man-in-the-middle relay, I can actually modify the radio capabilities and then I forward it to the network, and the network believes that these are the real capabilities of the device, and then it tries to save them, and then it completes the registration process. So what exactly happens here is that when I'm modifying the capabilities, I try to modify certain specific capabilities like the category of the device. Like the category means like, for example, if you have an iOS 11, it could be a Cat 19 device. Or if you have like an iPhone 6, it could be a Cat 10 device. So the higher the version of the phone, the higher the category. So I can actually lower the category, set it to Cat 1. Cat 1 typically means that it belongs to the IoT device category. And then I try to disable all the carrier aggregation and then MIMO features which are responsible for the high speed. Then we try to disable all the frequency bands, then remove the voice over LTE capabilities, like which is a traditional way of doing phone calls in LTE networks, which is comparatively more secure than doing calls on circuit switched mechanism. Then we try to remove the V2X capabilities. So by doing this, you're actually telling the network that you're not supporting any of these capabilities, and then you're actually trying to downgrade the capability of the device. So you're telling that this is not. This is basically an IoT device, but not a real phone. So we try to. So this is a trace from one of the operator networks where we see that the security mode command is actually happening after the capabilities are requested from the or received from the phone. So we tried this kind of attack on I think around 32 networks. I think it's the next. Okay, so we tried to do this attack on 32 networks, and then we found that 22 of them are actually following the procedure of asking capabilities like before actually setting up any security. So this gives more advantage for the attacker to modify them and then succeed with it. So once the attack is done, like what happens is like basically the phone is entitled to receive up to 50 Mbps of speed, but after this it would go back to like 2 Mbps or something. So even lower depending on like high peak traffic hours. The voice or LTE calls are denied, so you'll be obviously pushed back to 2G to actually do the voice calls. And then since the device is not supporting any type of like LTE based frequency bands, it would be pushed back to 2G to actually do the voice call, and then or even during handovers, like you would be downgraded. So this is what's happening. Like you're actually telling the network that this is not a phone, but this is an IoT device. So your service is like somehow killed. And then the craziest thing was like the capabilities are actually stored at the network. So which means that the network is storing modified capabilities for up to 7 days or until you restart your device. So basically you require a restart to regain from this and then get back to normal service. So you could ask me like, okay, why the capabilities are actually taken before the before the security? This could be there was like some reasons in the standards, like this is just for early optimization, like trying to get a better service or connectivity for the device. Then we try to repeat similar kind of attack on narrowband IoT devices where we are trying to remove the power saving mode capabilities. So the device tells the network that I would like to enable the power saving mode. So basically the device is going in an off mode when it completes a registration. Basically it's sending only a few bytes of data, so it doesn't have to be on all the time. So it goes off, but after the attacker has actually modified them, the device actually never goes off, and then it would stay alive for like maybe 13 days or something. So basically during these 13 days, it's just monitoring the signal strengths of nearby base stations and then trying to waste its power. So a device like which is supposed to run on 2 AAA batteries for like 10 years is actually being killed in like maybe up to within 13 days. And then the other problem with this device is like it requires a restart to actually get back in normal service. But I think it's really impossible to actually restart IoT devices like which are located like far away. So we'll see some of the attacks on ACA protocol, and then I think Ravi will take all this.
So this is first about on the radio side. Yeah, this is about the radio side first. And this is only about changing the message types, and then you try to pretend to device or reduce the speed, for example. But now going a little bit further on the next protocol, so what we can also do as well is basically what Altaf shows you right now is before this level, but now we talk about the next protocol sequence, basically where a mobile device sends his identity to the network. And in 5G, this identity is no longer MC, and this has been protected now. So you can't really steal somebody's MC over the air. That's what basically classical MC catchers do. So you won't leak here. Now in 5G, we have encryption on MC, and then no longer able to identify the device. But you can still make a fingerprint based on this. But now we have a second attack which allows you to detect a particular device without using this one. Then something new we're going to talk about. So basically we're going to steal the authentication material which is still in plain text. Okay. So you can still fetch those data from the network, and you can exploit the resynchronization errors what you get from the protocol. And this is like a part of attack vector. So I'm not really going to make complicated, but I will just explain you in a short picture what the problem is basically. Okay. And I explain in a simple term. Now everybody does some security. I believe the protocol you know. So what happens basically, you have a mobile phone and you talk to the network, right? And you says, hi, this is me. I want to talk to you, right? Simple thing. Then network says, okay, you want to talk? So let's have a challenge, right? I send you a random number and I send you a challenge, and let's verify whether you are the right guy or not. And you need to respond with the challenge response, right? And if his response is correct, then you are authenticated and you can talk. That's what the protocol. And that's what the same principle we use in mobile network. And that's what we have a random number and AUTN. Okay. And now we go a little bit deeper what it looks like. Not going to explain more critical things, but the point is, random number is just a random number. The main key part is AUTN, authentication vector, that consists of C and MAC, okay? And this has been constructed like this. So C1 means basically a sequence number XOR with AK. So it means that this challenge contains a sequence number, and the sequence number has been added to protect against the replay attack. It's logical, right? So if I'm sending a authentication channel and random number, I need to have a sequence number. So the next time it's replaying, I should know that it has been replayed. So every device stored a sequence number. Okay, this was a sequence number as already used, and somebody is trying to replay. Don't use it. So sequence number +1 for the next time, right? And this is what happens. Sequence number 2 XOR with AK. AK is called anonymity key, which is derived by some fashion. So for this context, just assume that this is the encryption key AK, right? Now assume that this is the first block. I do one random attack and I collect these authentication tokens, for example, and I basically gonna get a response like store, which is in plain text. C1 is equal to SQ1 XOR AK. And after 2 hours, I respond the same message to same mobile phone. I get a response because he's right now at sequence number 2. Because he has made a number of phone calls or something like this, his sequence number has been incremented. Now, if I combine these two values, C1 XOR C2, so basically you're going to XOR the same keys values because it's the same key, AK. It get XOR, it get cancel out. And what you get? Sequence number XOR with sequence number 2. You get some value. Now, we just need to use mathematical some equations to deduct some keys out of it. Can we really try to infer what is the sequence number exactly this mobile phone is? And we came to a conclusion like, if you do this attack, actually we can certainly learn some sequence bits of sequence number 1 or 2. So we can really tell that, okay, this mobile phone is right now at 67 number sequence number. Okay. And the funny thing is, every phone has a unique sequence number. And this allows us to learn exactly, this is, for example, my mobile phone will always use some unique sequence number. And this has been designed in such a way that every phone is being allocated some unique sequence number. And actually I can always see that, okay, this phone has the same sequence and it gets +1. It's like 67, 68, 69 something. So I always know the range, for example. And what it tells me, if I do attack on my phone, I can see that right now I'm at 67 number. And if I do this attack tomorrow again for the talk, let's say I made 10 phone calls, I use data connection. So maybe my counter goes from 67 to 100. So it tells me that I use my phone for some calls or some data. But if I don't use anything, I can tell that his phone may be switched off or something like this. So you can predict what exactly he's doing a call. So you can try to make a service consumption or monitoring attacks using this one. So all these attacks has been informed to the 3GPP body. So we tried to talk with them last 1.5 years. So what Altaf initially mentioned, this has been quickly addressed because this was critical. And then they said this, we need to patch it. So long discussion has been made and the standard has been fixed now. So this battery drain counter and those capability reports should be only asked after the authentication. So this has been fixed in the standard, but still some early 5G devices which are already being rolled out, they won't have this fix right now. So this will come only after 3 years, all those fixes, for example. And this protocol vulnerability ACA, which we talked, this will get addressed. So they are still discussing whether they should fix it, because the point is, this will only attack certain users. So if I want to make a dedicated attacks on Altaf, I can always track him, but only certain users. So it's a targeted attack, not a mass level attack that I can do on any phone, for example. So I need to know many information about him already, some authentication vectors from him to make the attack. So it's a still target attack. So they gave a low priority from the standard, but they are still discussing how we can address this problem in a phase 2 of 5G or try to prevent. And the same ACA protocol is being used in 3G, 4G and 5G. So that's the same principle what being attacked has been used in every generation from 3G. Yeah, this has been mentioned, and as I explained, this is the standard document that network should run the RRC UE capability inquiry only after the AS security. And this has been, the standard has been updated now. And information is also on the GSMA CVD program, which is now, if you work in telco, it's good to have, if you found something on any mobile network. So this is the responsible disclosure program for GSMA where you can report your findings. All right, and the fixes has been released. Some of the operators we've been doing research, we have been informed that this is a problem with your network and you should try to address. Some really, they were nice enough to coordinate with us and they fix it. Some other got warning from the GSMA or that's operator body and they inform all the operators in the world that this is you should do, for example. As I said, there are some new features in 5G that increase the attack vector as well. And also support of legacy systems. Like even if you have 5G, these networks or your device should also support the legacy systems, and then you have again the backward problems at the same time. But I end on the note, this is the statement from, so NATO released one document and many people talking about national critical cyber war with 5G or blah, 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 many things. But they have one interesting, unique point actually. So the NATO sees 5G as an emerging signal intelligence platform for collecting and processing telemetry data. And I think some point they are still right. Even though you have an application end-to-end security, like I can't really see what data is being covered by 5G device or any device, but using a telemetry data, I can still derive some intelligence out of it, as long as you collect. And 5G, if every device is going to talk to each other over 5G, due to the low latency or high speed, I wouldn't surprise that many people looking 5G as a one unique single largest collection of data, and then you try to derive some intelligence out of it. So that's like a really interesting point. Or I suggest you to read this document, which gives some highlights on this line. And we end on this note on time, I believe so. And we have a question and answer for 5 minutes after this. Yeah.
Thanks, Ravi. Thanks, Altaf.
Thank you. For the first attack, MNmap, you mentioned that there is also a passive attack available, right? Like visible. My question is, do you still need a base station, or you can like passively sniff the air for the signals?
Yeah, it's passively. Yeah, you don't really need to run a base station. So just you have to know like exactly which data you have to sniff. Then yeah, from that you can actually infer. If you have the model which we built, and from then it's just feed the collected information, just feed into this, and then it will spit you out like the required information that you are looking for.
The point is, if you had any SDR device which has a capability, if you have any radio device which has a capability to decode the 4G or 3G channels, and its data is not encrypted, so you can just dump out all the material. That's what the passive means, for example. We use the base station SDR because that was easy enough, but you can also do this attack on just having low-cost radio module and just dump out all the channels. That's also possible. But again, you have to decode those or filter the garbage data out of it. So it's just complicated, or things makes complicated. Yes, it's only with unencrypted, and the rest of the traffic we get is encrypted, but we can't really, or it's after the security session, so that's not interesting for us, for example.
Usually, you find these capabilities like unencrypted, so that was the basic problem of this one, and then now I think it will be fixed in the future devices. So,
do we have any more questions? Looks like that's it. Thank you, guys.
Okay, thank you very much.